Hey guys, welcome to a mock tutorial. In this tutorial, we'll be looking at limits, particularly how to know if a limit exists using the left and right hand rule. What does it mean when a limit exists? And what is the left and right hand rule? So the left and right hand rule states that the limit as x approaches a from the left hand side of f of x must be equal to the limit as x approaches the right hand side of f of x. How do you know that it's the left and the right hand side? It's given by these signs right here, the negative and the positive sign. We're looking at this function and then we're asked, does this function exist at 2 and 3? Now how would we find out? Well, we would use our left and right hand rule, which was given up here. So how would we start this solution? So we'd write back what we know. And right now, what we know is this basic formula right here. Now we're starting with 2, and we're going to look at these conditions up here. Conditions that contain 2. So we need a subfunction that satisfies a number less than 2. So if we look on a number line, 2 is in the middle, and on a number line, this would be the middle. Now the middle is 2. So now we have to find a condition that says the left hand side, which is a negative, so numbers approaching 2 from the left of the number line would be numbers less than 2. Therefore, x has to be less than 2. So that should be the condition for the left hand side. And for the right hand side, which would be a positive, numbers approaching 2 from the right hand side of the number line, which means x must be greater than or equal to 2. Now coming back over to our conditions, we realize for the left hand side, this ties in with our number line. And then for this condition here, x is greater than or equal to 2, which ties back into what we had over here. So we know those are the functions we're using and we know what side to put them on. Now let's continue to solve. Now we can substitute in our values. So we can drop the limit as x approaches 2. Now we can just substitute 2 as x. Now this is going to be 2 plus 2 is equal to 2 squared minus 2. 2 plus 2 is 4. This is 4 minus 2. This is 2. And this is 2. And we can see that the left hand side and the right hand side are equal, which means, so we can say therefore at 2 the limit exists. Now let's do the same for 3. So we look back up here. Let's clean this up a bit. And we're looking for conditions that contain the number 3. So we see second and third subfunctions have conditions that contain 3. Now let's draw back our number line. Let's erase this. We can write 3. For the left hand side, which would be a negative, we need to find a condition that satisfies x must be less than 3. And we see that in the second subfunction. So we know we can write back the limit as x approaches a negative of f of x must equal the limit as x approaches a positive of f of x. And we solve for the left hand side, we can write a negative of x squared minus 2 can take out the a positive and put in 3. Take out this and put in 3 as well. Now we need to find a condition that satisfies the right hand side, which means that x must be greater than or equal to 3. And we see that in our third subfunction 2x plus 5. So we just substitute it in for f of x. So now we have our new equation, and we can solve this direct substitution, where it's now turned into 3 squared minus 2 is equal to 2 times 3 plus 5. 3 squared is 9 minus 2, and then 3 2s is 6 plus 5, and we know that this does not equal, but if we work it out, 6 plus 5 is 11, 9 minus 2 is 7. So we can see that the left hand side is not equal to the right hand side. Now what does this mean? This means that at 3, the limit does not exist. Or for short, you can write D and E. And that's how you find out if limits exist. Thanks for watching. I hope it helped, and I'll see you guys in the next tutorial.